Okay, our first problem was a thinking one where we had to construct some identities and then operate on the problem. This one is another rectangular plot, and this one's classic because we do this in college algebra, algebra 2, college algebra, and now we're doing it in calculus. And that's where we have a natural fence happen. In the case of this one, it's a river. A rectangular plot of farmland, so rectangular is one of the key buzzwords, will be bounded by one side by a river. So we've got a river going on here. And then it says, and on the other three sides by single strand electric fence. All right, so I got my river. I have a rectangular, make my river longer. So, and then they're saying, we have a total wire, electrical wire, of 2,500 meters. What is the largest area? And you can enclose. Well, we need dimensions. We know that area for a rectangle is length times width. In this case, if we say width is there, then length is there, because the parallel rectangle has two sets of parallel lines and 90-degree vertices. So we know all of this information. So now we know, because we have this guy, we can make the statement that the perimeter cannot exceed, right? The perimeter cannot exceed twice the width plus one length. And the extent of it is 2,500 meters. So we're going to put everything in terms of the width. So I'm going to state that X is the width, and now I need what the length is. And so I'm going to have 2,500 minus the two W's, or actually I should make it X, but I will in a minute. So that my length is going to be 2,500 minus the 2x, because it's in terms of W. All right. So now we're going to construct our equation. And we know the area in terms of x is going to be the x, times 2,500 minus 2x. And we're going to clean it up. Similar to the one we just did. We're going to, now that we have our function, we're going to take the derivative to find our optimization. And we're going to set it equal to 0. All right, we're going to divide by 4. 6, and make it 24, 10, 2, 5, 625. Thank you. And this is in meters. All right, so now we're going to find the length. So that would make it 1250. So we have both of our measurements, and their question was, what is the area? That's right, I'm sure. I'm going to put it in the screen for those that are listening. So we've answered everything. The ones with the rectangles are super easy, and that's what you should expect on your exam. You know, that type. Here we have a very interesting one, and of course, this is where trig happens. All right. So it says two sides of a triangle are 6 and 9. Does it say it's a right triangle? No. So we cannot assume nada. Find the size of angle D, so angle theta. So we want angle theta formed by the sides that maximize the area of the triangle. And they gave us the formula. So we have the sides. We can say A is 6, 9. We don't know theta, and we have the formula. So now we're going to construct our function. All right, let me clean it up. Now we're going to take the derivative. That'll be the A prime of that theta is 2 54 halves cosine theta. All right. And now we're going to set it equal to 0. Do we care about the 59 halves? It's just a multiplier. And if we multiply both sides by reciprocal, it's gone. Because 0 times anything is 0. Is that okay with everybody? Or do you want me to show it? I better show it. Anyway, it doesn't matter. I don't care. I never worry about the numbers because they're going to be gone. Thank you. You may do that. Sorry about that. So I'm going to have 0 equal to cosine theta. So theta has to be between 0 and 90, possibly, or less than pi. But with 6 and 9, it's no, probably not, because pi would put it to it would be flat line. Does that make sense? Okay. So cosine of theta at 0 So we want cosine inverse of 0 is theta. So where is the cosine 0?
90 degrees.
Yes, pi over 2. Yes. That's the answer. 90 degrees is correct. Questions on that? Tell me if it's, not kosher. Oops. Okay. Let me do that right now before I forget. I just want to be able to hang this up. Oh, there we go. Somehow, when I do the movement, it just goes so easy on me. I'm sorry, that's a 0. Not to be confused with theta. Okay. Oh, I can erase this. All right, this next one is classic, um, classic calculus. But when I did this, and I will always remember that problem, it had a leak. It was a dy dx, and then a dy ds and a dx, because there was a leak in the trough. These are used to water, have water for cows in a pasture. These are used heavily. Anyway, my my first calculus teacher was a farmer, so he always had it with a hole in it because they leak sometimes, it's metal. And so his problem was that. Never forget it. But anyway, all we're doing though is maximizing the volume. This one involves the process of thinking and visualization. We have some given information, and we have a length. The length is easy. The length is that constant that's going to give us an edge on doing this math. But we're going to have to apply trig. Because we need the area of a trapezoid. And this is an isosceles trapezoid. And the formula for that is 1/2 little b plus big B times the height. All right, so we're going to do this in pieces. And we have, since it states on here that, that it is a rectangle within it, we know we have the 90 degrees. So these are 90-degree congruent triangles. All right? Does everybody understand that? Because this is 90 degrees and this is 90 degrees, and we have a one dimension that is also 1 foot up here. We've got a rectangle. Is everybody good? I have to make sure you all see what I see. Okay, So let's start with the easiest one. Guy right here. And here's our theta, because we want to, what value of theta would maximize the trough volume. So theta is opposite over hypotenuse, isn't it? Sine. Is that good? All right. So I have the height in terms of sine. Well, now I need the 1 and these two guys right here. Those two guys are adjacent sides. So what would I use? So we're saying those are the base. Well, we're going to just say x's because they're part of a base. And each one is cosine of theta, which is adjacent over hypotenuse, which is 1. And therefore, I have only the x to contend with. Is everybody comfortable with that? Anybody not? Well, now I have to do the big base. The little base is 1, and I have all my pieces. Is that true? Okay, I have my little base, my big base, I have my height, and my length is 25. So now I'm going to construct my function. It's an equation, really. But we usually call something like this a function because it has two variables, or one's an outcome and one's within the problem. That's why we say function. All right. So I'm going to say the area in terms of theta is going to be, actually, I'm going to say volume. Sorry about that. Volume is what we want. The volume is the area of the trapezoid, 1/2 of the sum of the bases times the height. And what are we doing? Multiplying by the length. How's that? Okay. I showed every step so nobody would get lost where I'm getting the information. Is everybody good? Okay. I'm going to clean it up. Sorry about that. I'm going to have the 25 halves up front. I'm going to simplify here. Bless you. All right. So now I'm going to, now that I have that, I'm going to optimize, right? So that means I'm going to take a derivative and set it equal to 0. I haven't been put into optimize, but I'm going to put it to this one. Okay, here we go. So my v prime of theta going to be, okay. Now this is a multiplier. The 25 halves is a multiplier. And I'm going to do the inside. The derivative, I'm going to do the first one. Derivative of a constant is? Okay, and the derivative of cosine is? A negative sign. Okay, and this is by sine theta. Now I'm going to do the other one. Sorry about that. Let me not put a parenthesis there, not to confuse anybody. Okay, so I got my first part. Now I'm going to put a plus, and I'm going to write the first one. Derivative of sine is, all right. Okay, I think I got it all. Check that I did, okay, because I did this first times that, then I did this times that. There it is, cosine of that and that. Okay, I think I'm good. And I'm going to have a negative 2 sine squared theta. Does everybody agree with that? Okay, and this negative plus 2 cosine squared theta. Everybody agree with that? I think. I'm looking pretty good, I think. Let me see if I did any bad math. Oh, I forgot the cosine. Nobody caught me. Hold that thought. Hold that thought. I'm distributing that cosine in there. All right, I like that. Okay. So, well, I got a cosine and a cosine squared. So what do I do with that negative 2 cosine squared? Oh, we got to make it all in terms of? What? What am I using? Yes. But that's not what I want. I say yes. Okay, all I did was do the math here and got this. I need everything in terms of cosine. So it's because I called you on it. You all know. All right, here I go. Yes. Oh, I love this. We're talking identities, right? So we know what? Sine squared theta plus cosine squared theta equals? Yeah, 1. Okay, so I want it in terms of cosine squared to be, or actually sine. Sine squared theta then is going to be 1 minus cosine squared theta. See or no? The identities are off of that first one I wrote. And you reminded me because I counted one of them wrong when it was the same thing because it was this guy. If I divide everything by sine, actually by cosine, I'm going to have tangent squared plus 1 equals, and that would be 1 over cosine, so that's cosecant squared. And that's what I was looking for, secant squared, rather. And I was looking for secant squared. I did it individually, and you did it by part. That was great because I said, oh, and when you mentioned it, I went, oh, I know that. Okay, so everything is from this, just about, that you would use. Is everybody good? Okay, so I'm going to do a little transfer identity. Now you all make sure I did all of my distributive property in order so that we don't have any question about Alma's math. All right, here we go. So let me clean that up again. Now you don't have to take all of these steps, guys. I promise. You all are smart, and it'll all work out. And I left off my 2. Thank you, Aaron. It's a little poo. It's always the little poo that gets me. So I'm going to clean it up again. I'm going to have the 2 cosine squared theta plus 2 cosine squared is what? 4? Positive 2 cosine theta. And then I'm going to have the minus 2. I'm supposed to have it factored. So I did something wrong because I can't factor that. It's not a perfect square. And I have a minus 2 at the end. I know this is right. Let me look at what else I might have distributed wrong. This was right there, right? 1. Wait, let me see what I did there. This was 1 plus 2. Yep. And this one was this base, and that's right. And then a half. Oh, it's probably because I didn't take a half of it. Let me take a half of it. Two and one. Yeah. Now I can factor better than what I had. Is everybody comfortable with that? Does everybody see that I just divided by 2? Yes? Okay. Okay. And so on this guy here, I'm going to have 2 cosine theta minus 1 times cosine theta plus 1. All right. And you know, we don't want a negative measurement because we're going to set it equal to 0. So the 25 is gone. Is everybody good with that? Nope. Left of a critical point out. So we've got cosine theta equal to 1/2, and we have cosine theta equal to -1. Well, -1 is not what we need. So all we need is this guy. So this is at, sir. And that's what we have. Is everybody comfortable with that? Comfortable. Okay. So now that I have pi thirds, okay, and they find the volume. Okay, here we go. So we're saying our height is sine theta. Well, sine theta of pi halves, of pi thirds, I apologize. It's the square root of 3 over 2. Yes? And cosine of theta is x. And so the cosine of pi thirds is 1/2. All right. So the width is 1 plus 2 cosine theta. So this is going to be 1 plus 1. It's going to be 2 because it's 2 times the half. So I've got the, well, the base here. Okay. So now, all right, I think I got all the pieces. I got my height. I got my bases. The length, actually, this should be length. And I didn't write that, base. It's a big base, the base. I put it as a base. So it's a 2. All right. So now I can put them all in. Here we go. So we said the volume of this object with the theta is going to be 1/2. The little base is 1 and the big base is 2 times the height, which is the square root of 3 over 2 times the 25. All right, so let's see what kind of math we can do here. I don't think they wanted, I think it was an exact answer, if I'm not mistaken, but I could be wrong. This is a 375 halves, a force, times the square root of 3. And this is in cubic feet. Ta-da! Did I lose anybody?
So what was our angle?
I don't care. We wanted volume. We just needed that. We had the identity of the pieces. I only used theta to get the size of the lengths. The height and that. Well, the height was a square root. For the cosine, it was a half. So a half and a half is 1. Rabbit, any way you can. You utilize every knowledge piece that you have. The theta was unimportant, and it just wasn't there. It for volume. Is everybody get it? And you know what the angle is, by the way. If it is the square root of 3 over 2 1/2, what is the dadgum theta? 2. If the cosine is a half and the sine is the square root of 3 over 2, what is the angle? Yes, but what is that in degrees?
60.
I thought it was 45, right? 45 is, it doesn't do it because it's the same. For optimizing. You need a little sideward, right, without it being flat and the water going everywhere, right? All right. Thank you, guys. Are we good? That was an awesome problem, right? Aren't you glad I didn't put that there was a leak in it? Yeah, I mean, I'll never forget that problem. It just blew my mind. And then he said, well, how long will the water have water in there for the cows? I said, oh, Mr. A, I don't want to know how long the cows have water. Yeah, it was, I took Mr. Allison, and he was here. He's another 50-year guy. And I went through here to relearn some calculus before I went in to mathematics. And I took him. Oh my God, he wore me out. He was fantastic. All right, here is a breather. This is our last one. Here's our breather. This one gives us the function, and we're visiting what we've known all along. And they're just putting it in as an optimization of what would it take to move this object in an optimum form. It says the height, feet, of an object moving vertically is given by s equals negative 16t squared plus 176t plus 132, where t is in seconds. Find the object's velocity at time 6. Time equals 6 seconds. And the maximum, it occurs when the velocity is 0, where s is 0. That means it in the ground, right? Okay, all right. So let's do the first part. Find velocity of object at t equals 6. All right. So we have to know that velocity is a derivative. All right. Good math, right? Okay, we're going to set it equal to 0. Oh, no, not yet. Sorry. We're going to do t equals 6. Sorry about that. I was already on the second part. And that was a minus. No, it's a plus. Sorry about that. Plus. I was already going to make a super mistake. Say, I'm going to look at it and say, what? Okay. Calculator time. What did you get? Make sure my math is good. And this is because we've taken a derivative and it's only the first derivative, it is going to be in feet per second. All right. Now, the second part says maximum height. Velocity at s equals 0. So if we want maximum height, we set the derivative equal to 0. So let's do that first. This is a plus, and I don't know why I'm keeping a, I guess I'm going in a hurry. I have no idea. I don't know why. Oh, thank you. Thank you for that. So now we're going to do S of that 5.5. Oh, Alma, but right. Plus, plus. No minus, no plus. Oh, did I do wrong? Let me look. A negative?
It's supposed to be 132.
132. Oh, I got you. Thank you for that. Appreciate it. It looks like 616. Is that what you all got? All right. Then it says its velocity when S is zero. So when S is zero is when it hits the ground, and we need to know how long it took. So we're going to set S equal to zero and figure that out. Is everybody comfortable with that? So in this case, I have 0 equal to negative 16 t squared plus 176 t plus 132. I think all of them are divisible by 16. That's what they usually make these problems pretty easy.
132.
Oh, is it? It's not, didn't come out right? Damn it.
Somehow would be nice.
Oh, okay. By 4, but it's not really going to help me, is it? Uh, Okay, all right. Oh, I was hoping it would work out so clean. Okay, so we can use a quadratic formula or we can factor, whichever way you want to go. But what is 132? Is it a perfect square? No? Let me see. This is 6, so it's divisible by 6. 22 times 6. Let me see if that'll work. 22 times 6 is 132, and I need 170. And this is 4 and 4 on the first number. So one of them has to be larger than the other. The plus has to be 4. That would be 88. What times that? I might have to use 8. 8 and 2. I have to use 8 and 2. Okay, because that would make it 16, 160. Yeah, I thought about that. I'm going to do that because my numbers are so big, because I think I'm going to have to make that even larger. And I'm going to do a negative, so you'll understand that. So that would be 4, 4, 4, 3. I'm sorry. Yes, by 4, 3, 3. Sorry. 4, 16. 16 is 4. 4 into that is 12, and yeah, 33. Okay. Well, that's a little bit better. So I've got 33, so that's 3 and 11, and that's all it can be. And then the 4. But I'm not going to get it unless I did some bad math. We're going to have to use a quadratic. I'll use a quadratic. I'm going to not use that. I'm going to use my normal numbers. Okay. All right. So using this quadratic, I'm going to, this is negative, but this can be positive or negative. And we're going to need the negative, I bet. We'll try it both ways. Ah, it sure is a -4, and I don't know why I put a 2. Probably a brain fart. And that's a negative. So no, I needed the positive. Oh, I mean, I needed the negative. Sorry. Yep. And but it should have come out positive. So oh, but no, doggone it. The, yes, because it is. Uh, it's a negative. I use the original. -16 is A.
Oh,
Okay. And this is velocity hitting the ground. And I'm going to say this. I don't know. I'm not sure. I think I made a math error on this guy. Let me think about one, but everything else is correct. Because I mean, I did. It should be positive. It's not supposed to be negative. So I did something wrong. Y'all find that one. Thank you very much, guys.